Welcome to a new deep dive. Today, our topic is the AJA FiDO-T-ST transmitter. We are pulling from a technical spec sheet and a storefront page from HDTVSupply. Our mission: to decode how this unassuming piece of broadcast tech moves high-quality video over seemingly impossible distances. So, okay, let's unpack this. Imagine you are watching a massive live stadium concert, and the camera focuses right on the lead singer.
Right, and you expect that absolutely perfect picture on your screen.
Exactly. That flawless, uncompressed video gets beamed to a production truck miles away. And if you have ever wondered how that signal survives the trip without dropping a single pixel, well, the secret lies in devices exactly like this.
It really is the unsung hero of live broadcast. I mean, we're so used to analyzing high-end cameras and switchers,
Oh, yeah, the flashy stuff.
Yeah, the flashy stuff. But none of that matters if you can't actually move the signal. And when you were dealing with live event logistics, traditional copper video cable just hits a physical brick wall pretty quickly over long distances.
Right, because with copper, the signal naturally degrades the further you go. You literally lose the picture. But the FiDO-T-ST sidesteps that limitation completely.
Yeah, what's fascinating here is that it takes a standard one-channel 3G-SDI video signal and converts it into single-mode ST fiber. And that allows for cable runs of up to 10 kilometers.
Wait, 10 kilometers, so that is what, like 32,808 feet?
Exactly, over 6 miles.
Wow. I mean, it is the equivalent of running a video cable straight through the heart of a major city without dropping a single pixel. But how exactly does it push a heavy broadcast signal that far without turning it to mush?
Well, it comes down to how single-mode fiber handles the light. Instead of bouncing light off the interior walls of the cable like multi-mode fiber does.
Which causes it to get muddy over distance, right?
Right, exactly. The signal overlaps and gets muddy. But this device shoots a single, extremely narrow 1310 nanometer laser straight down the core.
So the light isn't ricocheting around inside the cable?
No, it stays perfectly linear. And because of that, the data stays totally intact over that insane 10-kilometer stretch.
That is just wild. It's basically firing a laser pointer straight down a 6-mile glass tube. But looking at the specs here, they also emphasize electrical isolation.
Oh yeah, that is a huge factor.
I know ground loops are just a constant headache for anyone working in live audio and video, but how does translating the signal to fiber actually solve an electrical problem?
It absolutely does. Think about the physics of traditional copper runs. Trying to send a clean electrical signal across miles of copper is, well, it's like trying to pour a perfect cup of coffee while standing in 2 separate boats on a choppy lake.
Oh, I like that analogy. So the ground potentials between the stadium camera and the truck are constantly shifting.
Right, and that creates electrical interference. The boats rock, the coffee spills.
And you get that awful hum in the audio or those rolling bars in the video.
Exactly. But by translating the electrical SDI signal into light pulses over glass, the FiDO completely severs that physical electrical connection. You aren't standing on the shifting boats anymore.
Because light doesn't carry electrical interference.
Bingo. The ground loop problem just ceases to exist entirely.
Okay, here's where it gets really interesting. Because you would naturally expect a device pushing a 1310 nanometer laser across 10 kilometers to be this massive, power-hungry machine.
You'd assume it needs huge cooling fans at a heavy power brick.
Yeah, but the reality is the exact opposite. It weighs exactly half a pound, and the spec sheet says it draws a maximum of only 2 watts of power running off a standard 5 to 20 volt DC supply.
The optical components are just incredibly efficient. It doesn't need heavy heat sinks, which is why the enclosure is so remarkably compact.
And low profile, yeah. I mean, you could tuck this right behind an equipment rack or hide it in the truck or mount it directly to the camera rig.
Without throwing off the operator's balance.
Yeah.
Because in a decentralized broadcast setup, space is your most valuable commodity. But if we connect this to the bigger picture, it doesn't just pass the raw video data.
Right, because we aren't just sending raw video on these shoots anymore.
Exactly. It maps the entire SDI signal perfectly to the optical domain. That means it passes all the ancillary data too, including HDR metadata.
Oh, wow. So you keep all that high dynamic range information, the rich colors, the deep shadows, it all makes the jump.
Precisely. It guarantees that the absolute highest visual fidelity is maintained from the moment the light hits the camera lens through 6 miles of glass fiber all the way to the control room monitors.
So what does this all mean? Essentially, the AJA FiDO-T-ST completely shatters the physical limitations of video production. It replaces heavy, interference-prone copper spools with lightweight, electrically isolated fiber in a half-pound box.
It really is the invisible infrastructure making massive, decentralized live events possible. And this raises an important question. If a pocket-sized 2-watt box can instantly shoot a flawless HDR video signal through 10 kilometers of glass fiber today, how might this invisible optical infrastructure completely reshape the future of live broadcasting as our data demands grow even larger?